Alright, so today we'll be solving AMC 10, 2023, problem 24. So here, the question first says, 6 regular hexagonal blocks of side length 1 unit are arranged inside a regular hexagonal frame. So the 6 regular hexagonal blocks are going to be here, and the regular hexagonal frame will be this outside frame. And these, in the sentence, it says that each hexagonal block has a side length of 1. So here, I have a diagram to show you, and so what it means is just that here, this distance is 1, this distance is 1, and this distance is 1. So any distance that is the side of the hexagon is just 1, except for the large hexagon, of course. So here, now next, in the question, each block lies along an inside edge of the frame and is aligned with 2 other blocks as shown in the figure below. This means each block, so see here, each block touches the edge of the hexagonal frame at least once. Here, 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 and then etc. And also it says that it touches 2 other blocks. So now here it says again, the distance from any corner of the frame to the nearest vertex of a block is 3/7 units. So that means here in the corner to any vertex, the closest vertex will be 3/7. And here, the closest vertex from this corner will definitely be to here. So that will be 3/7. Now, finally, it's asking, what is the area of the region inside the frame not occupied by the blocks? So, the easiest way to solve this problem will definitely not be finding this Ninja Star Shuriken and these 6 weird objects. So, it would be easier to find the area of the hexagonal frame and then subtract of these 6 gray hexagons, especially because the 6 gray hexagons also are regular, and that means they're congruent. So, here, the easiest way would be, if you already know the formula of a hexagon, which is 3√3/2, then it would be easier to solve this. But let's just assume that you do not know this, since most people don't know this. So, how to find the area of hexagon is first, you have to draw these 3 lines. These 3 lines make 6 equilateral triangles. So now, more people know the area of an equilateral triangle, which is √3/4a squared. The area of this is √3/4a squared. But where a, lowercase a, is one side. But what if you don't know that as well? Then what would you do? Okay, so now I'll show you how to find the area of an equilateral triangle. So first, you have an equilateral triangle, label every side a. So I have to find the area of this triangle. And the area of a triangle's area equals half base times height. So here, we know that the base is a, so a equals half AH. So, we need to find h. So, we're going to draw h here. And this h is going to bisect the base, which makes that this is half a, and this is also half a. Also, this will become a right triangle, so you can use the Pythagorean theorem here. So, h squared plus half a squared equals a squared. So now, h squared plus 1/4a squared equals a squared. So you subtract minus 1/4a squared on both sides, which becomes a squared equals a squared minus 1/4a squared. So then h squared will equal 3/4a squared. But now you're going to root this. You root both of this. H equals √3/4a. Since a square and a root will just become the number inside of it. So now we have to simplify this, where h equals, because we know you can separate this √3 and √4a. But now you can recognize that √4 is actually just 2. So you can reduce this to √3/2a. So that becomes h. So now you just have to plug in h here. So a equals half a multiplied by root 3 over 2a. So this becomes, you multiply the fractions, which is root 3 over 4, and then multiply the a squared. So that's how you find the area of an equilateral triangle. Okay, so now that you found the area of an equilateral triangle, which is root 3 over 4a squared, we can plug in a as 1. So then the area equals root 3 over 4. Now we have to find the area of not just this one triangle, but of these 6 hexagons first. So to find the area of these 6 hexagons, because there are 6 equilateral triangles in a hexagon, you have to multiply by 6. So we can multiply by 6. And then because there's also 6 hexagons, you're going to multiply by 6 again. Eliminate. This becomes 2. This becomes 3. Eliminate again. Becomes 3. And this equals 9 root 3. And now, the frame, now we found the area of the gray hexagon. But now we have to just find the area of the frame. So let's just label the area of the frame as F for frame. And because we already have H's height. So F minus 9 root 3 equals question mark, which is what we're trying to find. So now we have this, but we can also find the area of a hexagon. You might wonder how can we do that? Because we already have an area of equilateral triangle, we just have to multiply by 6 to get the area of a hexagon. So root 3 over 4 a squared times 6 just becomes 3 root 3 over 2a squared. So now that we got that, all we need to do to find the area of this frame is just to find this length. So first, we already have these 2 lengths. We just need to find this length. So first, we have to draw a line here. Let me fix it a little. To make a parallelogram. And then, because this has to be 1, because this is a parallelogram, this will also be 1. And because this is 3 over 7, this will also be 3 over 7. So now we find 1, 1, and 3 over 7. We just have to find this length now. So luckily we have this trapezoid, and we can use this trapezoid. I'll just move everything down a little bit so that we have space for a trapezoid. So, and we can also notice that this is 1 because this is a side of the hexagon. So let me just draw my hexagon, no, my trapezoid here. Okay, so here's the trapezoid. This has a 3 over 7, and this is 1. But rotating it will probably be better. So I'll just rotate it for you guys. It won't make any difference. You just have, because since the only thing you have to find is this or this, it doesn't matter because this is isosceles trapezoid. So both of the lengths are the same. So if you just find one length, basically, it's just this length. So you can draw these 2 lines, and then this will now become 3 over 7 since they are straight lines. And then now, because this is isosceles trapezoid, this and this will be the same. Now we have to subtract 1 from 3 over 7, which becomes 4 over 7. And 4 over 7, we have to divide it by 2, which becomes 2 over 7, 2 over 7. Okay, so now we have this right angle. So now you might wonder what we do next. So now it's a bit of a twist here, as we need to find this angle. So to find this angle, you might wonder, how do we find that? So first, you gotta find, because it's a regular hexagon, this angle, this angle, this angle, this angle, this angle, and this angle will all be the same. So if we just find the area, the total degrees of angles, then we can just divide it by 6 and we can just get the number of one angle. The easiest way to do this is to draw triangles in here, which you can draw 4 of. And then because one triangle has 180 degrees, that You multiply that by 4, which becomes 720 degrees. So now, this is 720. You have to divide it by 6, which becomes 120 degrees. Now, we can apply that for every hexagon here. So first, I'm going to apply it here. This is 120 degrees. And because this is a straight line, this has to be 180 degrees. That means this has to be 60 degrees. And this will also be 60 degrees because this side is also sharp, right? So this will be 60 degrees now. So because this is 60 degrees, let me fix up this. So it looks kind of weird. That will signify that we can use, because this will be 30 degrees here. So now we'll use this triangle, as these are both the same. We don't need to use any. So now we can use cosine here. So you can use, if you know that cosine 60 degrees equals half, then you can notice. And you have to know that cosine equals adjacent over hypotenuse. And this in this case, because the angle is here, this is the opposite, this is the adjacent, and this is the hypotenuse. Okay, so we already know what the adjacent is, 2 over 7. So that will become cosine 60 degrees equals 2 over 7 over, let's label this x. But then we already know cosine 60 degrees equals half. So that means half equals 2 over 7 over x. Now, if you know ratio, that means you can use the butterfly method where you multiply these two numbers and these two numbers, which becomes x equals 2 times 2 over 7. So then x equals 4 over 7. Wait, what happened? So now here you can figure out x equals 4 over 7. So now you have to add these up. And then don't get confused with this. 3 over 7 as this is this length, even though I drew it here. So all you have to add is 3 over 7, 1, 4 over 7, and 1. So 3 over 7 plus 1 plus 4 over 7 plus 1. So now you can figure out that 1 plus 1 equals 2, and then these two equals 3. So this equals, these two fractions equals 1, and then 2 plus 1 is 3. So now you know one side is 3. Now we can plug in the formula, which is 3 root 3 over 2 multiplied by 3 squared now. So this equals 29 times 3 root 3 over 2. This equals 27 root 3 over 2. So now we found the area of the hexagon. So of the large frame hexagon. So that becomes F, and then we can plug in 27 root 3 over 2, if I'm right. Yep. Minus 9 root 3. And now, this as a fraction, you can make this a half fraction too, which becomes 27 root 3 over 2 minus 18 root 3 over 2. And this, I have to move this down a little. So then now we're very close to the answer. And then you just have to know what 27 minus 18 is, because everything else is the same. That becomes 9 root 3 over 2. So now that will be our final answer. And now we have to find if there's a 9 root 3 over 2. And boy oh boy, there's a 9 root 3 over 2 here. So that means the answer will be C, 9 root 3 over 2. Thank you for listening, and bye.